Hello and welcome to my shop. This is a demonstration video about my 320 fuel cell. First I'm going to go through and take you through a little tour of all the components and what kind of current we're looking at. And then I'm going to set the camera down and do a timed test where I will fill up a 500 milliliter bottle in approximately 10 seconds, or about 3 liters per minute. So I'll go ahead and move in here, and first we'll start with what is giving us the power, and that is our trusty old die-hard battery charger. And if you look on there, the amp, let's see if I can get a better shot there, you can see it a little bit better. We're reading out just a little under 50 amps output on the battery charger, and the voltage is approximately 12.2 volts. And so we'll come around here and I'll just show you, everything is connected there to the battery, and this right here is the power supply. This takes in approximately 50 amps, and it turns 50 amps into a higher voltage, approximately 48 volts. It's adjustable, and the output, the input is there. It has a, if you look right here, is a thermal cutoff. If anything overheats, it will shut the system down, and that's resettable. And then this plug here is the output on the battery supply. That white wire that runs over here, I'll show you a little bit better of that from the other angle. That is the sync wire. That's what goes to the controller and turns the entire system on. And then it runs around here to a plug, which has, what you're seeing there is a 3-conductor plug, 12-gauge wire. And the yellow wire is the positive on the cell, and the green wire is the negative, and I have that running through a amp meter, so you can see how much amps is actually coming from the power supply and flowing into the cell. I forgot my temperature gauge here. We can see, this is a good angle to look at the temperatures of the cell. It's been running off and on all day. It's up to full power right now though. And we're looking at 121 degrees in the accumulator. I call that an accumulator tank. And then the cell itself is looking at 106, 108, 110. Kind of deflects off the heat sink sometimes. So let's say give it 120. Now I always check the cool end, 110, and the hot end is 138. And that's about normal operating temperature. 140 or below is good. These are air-cooled cells. That is a 127 millimeter fan that puts out approximately 140 CFM, I believe. So let's move around here. I did want to show you one thing. You notice how heavy the gauge wire is, and I use actually just 2 lugs bolted together. I found that to be the best way to hook up the conductors to this. Otherwise they tend to generate a lot of heat and you end up with a lot of losses just in wiring. All this wiring is, once you get rid of all those losses, it stays virtually room temperature or ambient. It's probably just slightly above room temperature. Everything runs nice and cool. Now coming over here, I wanted to show you the voltage and the amperage. Going into the cell is 47.1 volts, and our amps, I took the cover off there because it kept blaring. So we're looking at approximately 12 amps. Approximately 12 amps going into the cell. And we're at about 3 liters per minute. and we can see the, let me put out my little tripod here. You know, that is a darn good flow of gas coming out of that. And the interesting thing is it's not steam. There's no real steam coming off of that. I'll show you from another angle. You can see what looks like steam, but is not, because obviously we're not hot enough. So now I'm going to go ahead, I think I'm just going to go ahead and leave the camera running. And I might edit that out later if I figure out how to edit. I have not spent much time trying to publicize this because I was too busy working on it and it would bother my focus, so I just decided not to do that stuff until I was ready. So now I'm going to go over there and I'm going to turn the machine off and hook up my bottle, and you can see on the right there is a timer, and excuse me, on the left is the timer, and the smaller numerals are seconds, the larger are minutes, but we'll be doing seconds. And then on the right, I went ahead and put that voltmeter up there so you can see, you know, that the current flow stays the same during the whole test. So I will go over there and take care of this right now, and hopefully everything will go well. I've had a heck of a time trying to figure out a way to demonstrate this clearly. This is the best I came up with so far. I think I'll probably get better as time goes on. Okay, put that in there. Now I'll turn the system on, and it takes just a little bit of delay to flush out the line, and then I'll hit the timer and take a look at what the seconds is after we're done. So, we are at 11 seconds, give or take a few tenths of a second. I'm going to go ahead and pick up the camera because I don't know if you can actually see that from there. So you can see that 11 seconds. Usually it's 9, 10, or 11, just about every time. And it doesn't do tenths of a second, so we can't really see that. And that is at 12.2 volts going in, at about 48 amps. We have 12 amps going into the cell at 46.9 volts. Cell temperature 113. Cool end 119 on the hot end. On the heat sink 116. So that's my demonstration of the 320, and that's what 3 liters a minute looks like, or 2.875 or 2.773, somewhere in that range. Anyway, thanks for watching.